So today we're going to talk about a project that we're working on with a few of us looking at variable rate irrigation. And really what we're trying to do with this project is we're trying to build a system that can a dynamic system that can update prescriptions in real time. So we're working with pivots that have existing VR capacity. So instead of coming up with a plan and sort of using that plan throughout the season, we're building a system that can update that plan sort of real time. So you have a prescription today, in a week you might have a different prescription, in 2 weeks you might have a different prescription depending on what the crop needs are, depending on how much it's rained, how windy it is, how hot it is, all these pieces. So that's really where we're trying to get. So we've got a few different partners on the project. Dr. Mark Johnson with the University of British Columbia, and I'll let you introduce yourself a little better in a bit. We have Kevin Cusson. He manages, he's building an open source platform that integrates a lot of these pieces together. Michelle Conchu has been a real help on the project. And we've worked with Nathan Stamp at Stamp Seed. So he's been gracious enough to let us work with his pivot in his field. Yeah, maybe I'll just hand it off to you. I don't think this mic's working, is it?
Okay.
Yeah. I'll hand it off to you to kind of introduce yourself. Sure. I don't think this one's working.
Okay, no problem. Yeah, good morning, everyone. As Lewis was mentioning, we are looking to develop a platform to provide variable rate irrigation prescriptions. But beyond that, we're trying to really take the information from in the soil using these soil sensors and then get that information into the cloud, where on the databases we can provide these models that are projecting what kind of irrigation is needed for the week ahead. So we use the weather forecasts, and we use those forecasts together with the soil moisture information to do the evapotranspiration projection, so how much water the crops are going to need in the days and week ahead. And then based on the soil moisture information from the field, we talk about when you're getting down to that kind of trigger point to wanting to refill the soil moisture profile to make sure that the crop is adequately supplied with soil moisture. So I'm part of this startup company called Ensemble Scientific, and we're making these soil sensors. They're adapted from the watermark sensor that measures soil water potential. And then we add a temperature sensor there because that improves the accuracy of the sensor, and then we make it a little bit easier to then get the information from this and up into the database where you can view it online and you can see what the projections are for the irrigation projections. And so what you'll see on the back of this handout is this plot that's got the red line. And so this is the soil moisture that's closest to the surface. And so it's, the plant roots are most active in the near surface, but that's also the area that's most prone to evaporation. So you've got both evaporation from that soil and crop water uptake. So it's really the one that's responding most to plant use, as well as it's responding quickest to when you get water inputs, either through irrigation or through some of the rainfalls that we've had lately. And you see these jumps in the red line. These first two were irrigation events that were programmed, and then these last two, where it stays high for a little bit on that red, that's the rainfall that we had there in a week or so ago that really recharged the soil profile, maintained it at a nice wet status for a few days, and then the plant started drawing that down as sunny, warm, windy conditions returned. And so this information, getting within the profile, allows us to know how much moisture is in the soil. We update this on the fly around the clock, and so this allows us to project forward together with this information you see on the other side that's got for the week ahead. This is the weather forecast. So we've got the temperature, the wind speed, relative humidity. So if it's a hot day, of course, there's going to be more water demand. If it's windy, there's quite a bit more water demand. And if the air is dry, it's going to be sucking up a lot of additional moisture from the field. And so these are kind of the three main drivers for what controls water loss from the root zone. and then we can get there might be some rain in the forecast, and so we factor that into our water balance to come up with these kind of projections of where the water is, the soil water status is going through time. So when we ran this over the weekend to prepare for this event today, the soil moisture was in a good level, and then as it started to the forecast for water use, drawing down water out of the profile, you start to get into this red zone, and so that's below 60% of available water. And so that's kind of, for this crop, which is dry peas, that's the threshold that becomes kind of yield impacting. And so if we can get water on before we get to that red line, we're going to be making sure that the crops are adequately supplied with moisture, and they're going to not have any kind of yield impacts. But then it might be that there's some, the weather's changing or rainfall is coming, so you can kind of look at this and you would see if there was some rain projected, these might come up. So you would then use this information to decide, is it time to irrigate or not? And so maybe with that, I'll turn it back to Lewis, who was talking about like when to water, how much, and those questions.
So I guess first of all, who's all an irrigator here? About a third. So how do you decide, how to irrigate, when to irrigate? Like, what sort of things do you maybe consider? Crop stage. Soil moisture.
Mm-hmm.
A little bit on forecast.
Cool.
Yeah. Anybody doing variable rate irrigation? Tell me about it. What's your experience with it?
Yeah, it's tough to say. It's a lot of planning and mapping. We kind of mapped all our fields, and then you can't really adjust them as much, or it's got to be out there pretty much to make sure they're always working. That's kind of good and bad about them. But.
And I think we've got that feedback a lot, kind of consulting before this project, is that we have this variable rate technology, but the dynamic side of it is really hard to implement. It takes a certain amount of time, resources, expertise to sort of build those maps, and then how do you adjust them sort of real time throughout the season so that they actually address what's happening in the soil, what's happening in the forecast, and what's happening with the crop growth, kind of these things that you guys had mentioned. So in our case, what we've done is we've got about 15 or 16 nodes of these sensors placed in the field, and each node has a sensor at 10 centimeters, 20, 30, and 50. So we've got 4 different depths, and as Mark mentioned, that lower depth we don't see a lot of change at this point, but those higher depths we can really see them spike and draw down over time. So there's actually a lot of questions that we've kind of worked through in sort of building this. Is 16 sensors sort of a reasonable density? That's one every 9 or 10 acres on your 140 acres, 130 acres of irrigated land. Probably overkill in our case, but it's going to help us if we find multiple sensors are responding the same way to rainfall and moisture application from the pivot, then we know that's duplication, and we can kind of reduce that moving forward. There's also a big question on zone delineation, and there's a lot of different ways to do it. I think the simplest way is, where are your problem areas? Where do we know it's always dry? Where do we know it's always wet? And you certainly want to manage those differently, but when there isn't those obvious zones that you either know or you can identify through various means, it's kind of a mix of art and science. There's a dozen at least different ways to sort of approach that zone delineation and what's sort of the boundary between applying a half inch here and 6/10 over here kind of thing. So I mean, all that to say, there's a lot of, I guess, uncertainty in the system, but having sensors in the soil that tell us what's actually happening is a big step forward from having a model that may or may not be correct, or zone delineation that may or may not be correct, that we're sort of making assumptions about how that water is going to behave throughout the season. So that's one of the big steps forward, is we have a pretty good understanding of the variability of moisture in the field, and then the next step is sort of that connectivity. I think somebody mentioned a pulse tool auger, so getting out to the field and actually grabbing a sample, whether you sort of do a hand moisture test, Maybe there's probes out there that, you know, I think there's some of those ones that you've got the probe that you stick in, you pull out, and you kind of get that measurement there. But it still requires you to be out in the field and collect that information. And then you still need to take that step to use that information to determine how to apply. And in a lot of cases, these samples are collected maybe 1 or 2 places in the field and may not reflect that variability. So all that to say is we're trying to build a system that helps us understand what's happening in different areas of the field. We're trying to connect that to a broader system that says, okay, we know what's happening in the field. We're going to autonomously build a prescription. We're going to send it to the farmer, and then you can decide whether or not you're going to say yes or you're going to wait a day to implement it. So I think a big step forward in taking advantage of this VRI technology that's there and actually being able to make it simpler to use and a little less time consuming and hopefully a little more accurate.
Yeah. So we're really in the kind of midstream on this research project where we've just yesterday have uploaded the first dynamic prescription variable rate, and so we've got you know, the crop is approaching flowering, and to date through the crop they've been applying just a static rate, and so we're seeing in the field already the higher spots are looking a little different than kind of the mid slopes, and then some of the lower areas are maybe a little bit waterlogged from all the moisture that we've been receiving. So we're seeing some differences in crop growth and crop performance, and we're hoping that by providing this variable rate prescription, applying more water where it's needed and less water where less is needed, then we'll kind of even out the plant performance and get a more uniform yield and crop quality. That's the goal. And so with the prescription that we put on yesterday, it's running so 14 millimeters, just over a ½ inch on some of the higher grounds, and it's applying 10 millimeters, so a little bit under a ½ inch on some of the lower grounds, right? And so that, you know, that's a 4 millimeter difference. That's a, you know, out of, what is that, a 1/6 of an inch difference. But then as you apply that, you know, throughout all the different irrigations, it can add up to significant water savings potentially, and then also, of course, energy savings. To the cost of getting the pivot to go around is not trivial. So that's sort of the goals, is to have this kind of feedback system that is providing information to the producer. They can then evaluate against their own experiences. They can accept the recommendation or not, and then kind of go forward. And yeah, with the goal of kind of evening out the crop performance in the field. So as you look around, you know, here we've got higher areas that are tending to dry out a bit more. The lower areas tend to accumulate moisture and hold on to those. So if we have the information on what's happening in the soil profile at these different locations, it allows us to put all that together into a dynamic prescription. And really, like on this research project, we're going way overboard in terms of the number of the sensors, and that's just because I think there's a lot of information that we can learn from that density. But from a practical perspective, a producer might want to have a couple of nodes that are in kind of a drier area or a wetter area, and then you can use that to get information about what's probably happening in similar parts of the field and use that in real time.
Mark, question.
Yes?
Your underlying assumption is that you want to even out the crop. Why not go maximize every area of the field?
Right. So that can be an objective in the model function as well. So basically, on this final plot here, you've got these blue squares, and they're telling you over time how much water is needed to recharge your soil moisture profile. And the lower bound of that box is going to be how much, it's a lower amount. So your wetter areas are going to need less. So that would probably help maximize the yield by not creating waterlogging, etc. Yeah. So in essence, I think we're talking about the same thing. You know, if it's even yield or it's just maximal yield, right? So, you know, there's kind of that balance point that producers need to consider. Is the total bushels what you're after, or is it maximizing the economic yield, right? Because there's sort of costs and benefits to what you're trying to achieve, right?
So are you able to individualize every nozzle then?
Yeah, essentially, what's not shown here is that the field gets divided up into polygons, and each polygon gets a rate applied. And so then as the VRI comes across, or as the pivot comes across, the nozzles are adjusting their pulse rates to apply the amount that's being asked for.
So in our case, we're working with pivots that have VRI capacity already, right? So we're trying to make better use of that technology by building a system that kind of capitalizes on what's there. So we're sort of limited by what that pivot has. So in our case, the pivot has banks of 4 sprinklers tied to nodes. So those 4 sprinklers in a row would sort of work in unison, but there's different configurations for different pivots, kind of depending on what we have. So
when you talk, these are real time.
yeah.
Are these actually tied then, like through Bluetooth or something like that, to the main?
So that's a work in progress at this point, but we have them connected. So Mark can see at any given time what the moisture level is at our dozen or 16 locations in the field. So we know at any time we can spit out a report like this that tells us exactly what's happening now, what we anticipate over the next few days. So we are connected enough to get that information on our side, but to integrate with some of the company's software is a little bit challenging, and I think we're sort of working through some avenues to be able to do that, but ostensibly it's possible. But for right now, we get a prescription on a USB and we can kind of plug it in whenever. But the idea is, down the road that you can sit on your computer, you get the report, you get the recommendation, and you say, yeah, let's go for it, or you know what, I'm going to wait a day because we're spraying today, kind of thing. So
Yeah, and all of this, it does depend on connectivity opportunities. So right now, where we are, it's got the office and homes around or near the field, and so we're able to get into the internet through that kind of wireless connection. But it could also be a cell phone SIM card that's uploading the information. But yeah, there has to be some kind of ability to push the information from the soil into the cloud, so to speak. Yeah. Yeah.
So, yeah.
Maybe you're going to get to this. I'm just interested, can you briefly explain the research side of it? Like with the plots, we see the different plots and they're in different areas. So do you have other fields, similar soil where you're growing the same crop? What does the research kind of look like?
Yeah, so in our case, so we're not doing the project on this field, but we've got a field by Enchant, and it's a pea field. So we've divided it up into zones. So it's the same crop the whole field, and then we're monitoring what's happening as we get rainfall, as we apply irrigation, kind of in each of those zones. So sort of a almost 7 or 8 acre kind of grid almost.
But you're also going to compare standard.
Yeah, that's right. Yeah, so then we will compare, pairs of zones. So if we have 2 zones that are quite similar in different parts of the field, one would get a uniform rate, so if we're applying between 10 and 14 millimeters, that would sort of get that blanket rate, and then another zone will get, a recommended rate from the system based on what's happening in the soil. So we'll be able to compare, how things perform as far as crop growth or soil moisture status between a uniform or a variable rate. So the uniform will apply the same amount on the hilltops and the valleys, whereas that variable rate will sort of, respond to that higher moisture levels in parts of the field. Does that answer your question? Yeah. So one thing, Mark, we kind of were out at the site yesterday, and Mark said something along the lines of all models are incorrect, but some of them are useful. So when we think about, and then this is something we've kind of run into a bunch as we've gone through this project. There's a number of different, even on a uniform irrigation standpoint, there are different approaches, different models you might use. Recovery of evapotranspiration is one pretty common one. So the more the crop's using water and transpiring, the more you want to apply water. But there's different, there's the AIM model, there's different models throughout the states, but none of them are perfect. Some of them are based on sort of climate norms. So we expect the climate to be this time of year, but those models don't know that we're going to get, 2 inches in the last 2 weeks, or that we might get no rain for the next month, right? So this is where sort of that real time, what's happening in the soil, really helps us a lot. And even thinking of it on a field basis, depending on what crops you grow, if you're growing a row crop, depending on which direction those rows are going, you might have different water flow patterns in that field, and that might change the size and shape of some of the zones that you think are there. So actually having this, ground truthing real time throughout the season is a big step forward, and I think it helps us to better utilize some of the variable rate technology that's out there.
Right, and so then with the outcomes of this project, we're hoping that they would have applicability for pivots that are managed without VRI, right? Because you do have the weather forecast and the crop water use forecast that can be generated, and then maybe it's more of an information of, okay, you need to do 3/4 of an inch now, or you might want to do, you know, a 1/2 inch kind of spaced out. That kind of information might be useful, independent of if you're putting it down at a uniform rate across the field, or if you have the VRI add-on to be able to really differentiate where it goes down. So hopefully it's, you know, more information leads to better decision making, which can improve the farmer bottom line.
And there is a certain behavioral aspect to this too that we're navigating as well. So, you know, so the farmer we're working with said, okay, we're going to irrigate today, and our model said, well, you know, we'd recommend 5 millimeters today, which doesn't really make sense to put that little amount on. So there's sort of that, you know, that interplay between, you know, what the producer's planning to do, what the model might recommend, and how do we adjust it. So, you know, do you put an inch on now, or do you put a 1/2 inch before it's ready and a 1/2 inch after it's ready? And, you know, where do you set your how full do you fill it? You know, do you fill it up to 90% field capacity, 80%? So I think there's a lot of places where, and I think we're moving sort of, in our case, to sort of a semi-autonomous system where we give recommendations and the farmer sort of says yes or no, because, or the farmer can maybe request a recommendation and maybe adjust it up or down just based on what they know is going to happen, or you know, again, there's the aspect of, okay, we've got field operations, or we don't want it too wet during flowering because we're thinking about disease or certain things, right? So, yeah, so I think there's a lot of pieces in place that I think we can fine tune, move forward. But at this point, I'd say we're pretty thrilled with what we've accomplished to be able to, you know, real time know what's happening and be able to respond to it. I think is a big step forward from a lot of the systems that are out there right now.
Yeah, so I think with that, we'd love all your questions and feedback. One of the other features of these, of course, is that, you know, you have to request the water with a day or so in advance, so you know, you're not going to be able to, you know, if the forecast kind of helps you do that planning, perhaps.
So when you are doing this modeling, like what are the major parameters and how you're weighting those parameters? On what basis, like you're putting more weight to the weather and then more weight to the moisture, like how you're defining those weights, and what are the major parameters you're using for modeling?
Right. So we've got the kind of the starting point of the forecast is always the current conditions, and so the soil moisture information from the field provides us with that starting condition, and then projecting forward, it's looking at the weather forecast, and then we put that through like the Penman-Monteith equation to project how much evapotranspiration is expected. So that's and then with the crop stage, we have the crop coefficient that adjusts the ET, and so then we see it's on this kind of the green row here, the ET crop. So that's the projection for how much ET would be expected. You see that for June 22nd, on Sunday, the forecast said that we're expecting 10 millimeters of crop ET, and that was based on it being quite warm, quite windy, and also quite dry in the atmosphere. I looked today at what actually was modeled by the ET model for yesterday, and it was 7 millimeters. Right, so there is a bit of play in this, and so it's not a learning system per se, but it does take into account the weather forecast to drive that ET model, as well as, so that's the ET withdrawing from your soil moisture bank, and then rainfall that might be adding some in. And so then if you know you have a irrigation planned, or you need to decide on which day to order water for based on your other operations, you know, these are all things that the producer would be able to kind of juggle and decide on the decision criteria.
We've talked a lot about how confident we are in the forecast, right? So, you know, if it's a 30% chance of 25 mils, you know, how do you consider that? And that might be sort of a case by case. Like every grower might have to kind of deal with that in their own way, you know, depending on a variety of factors. So it is tricky to be perfect, but I think we can do a pretty good job of improving and doing a reasonable job. And again, you know, that sort of opportunity to give oversight, or to you know, pull the plug on a prescription, or say, you know what, give me another suggestion in a day, is kind of a nice feature.
Does it even allow for real real-time wind. So as the wind increases, the irrigation then automatically slow down.
Once the prescription is in the system, at this point it's static. So if we give it a recommendation and it's irrigating a circle, at this point we can't make a change halfway through. So if conditions change and it does get windy, but our model does, like, we do account for, you know, if it's going to be hot and windy, there's going to be more evapotranspiration. We are considering that. And the soil moisture sensors, like, they'll tell us what the outcome is. They'll tell us what's actually happening, you know, at 10, 20, 30, 40 centimeters, right? So that's kind of our check on everything, you know. A model that's sort of built and says, okay, here's what we expect throughout the season. I mean, we recalibrate that twice a day based on what's actually happening. So yeah, I mean, the wind is a big factor, certainly here in Southern Alberta, right? So, and that's something where, you know, yeah, that sort of anticipation of it is going to be pretty important. And that might be a case where you'd irrigate more than the model recommends, you know, ahead of some of that dry weather just to stay in good shape.
Yeah, I think touching on that, it's really interesting. From where we are now, most pivots don't have VRI. And of the ones that do have VRIs installed, some of the farmers we're visiting there, it's difficult to get it to work optimally, or there's other barriers, and so there might just be a static prescription that's running, and then that's fine. So, you know, we're hoping to be able to improve that, and then maybe, you know, in the coming years we would then be able to add this kind of feedback system in, because if it is very windy, then your efficiency has gone down. So you might be telling the pivot to put down half an inch, but if quite a bit of it is drifting off, then, you know, it's not, you need to increase the rate to get the recharge that you're expecting, right? So there's, right now, you know, to get the prescription into the VRI system, you're either uploading the file off of a USB drive, or if you've got a remote telemetry unit that's patching in, then you can send that remotely, but they're not too common at the moment. So once, you know, if this technology takes off, if water pricing becomes a thing that people are concerned about, and then, you know, driving that adoption of that technology, then I think we'll see more of these kind of things coming online. But yeah, I think it's really interesting, the kind of the feedback and how you can program it. With Light Farm, this kind of notification system, they're talking about there might be useful for a pivot operator to get a notification if wind speeds are above a certain threshold. That, you know, here's a little text comes in and says, heads up, you know, we're expecting 90-kilometer-an-hour winds from off the mountains, and, you know, you might want to either anchor your pivot or orient it to you know, don't want any pivots getting blown over. So those are just, you know, some of the kinds of things that we can do once we have the kind of communication between the producer and the systems and things.
The sensors, are they meant to be installed and left there permanently, or do you install them every year?
Yeah, right now they're installed. You get like it's called a ship auger, and so you just drill in, and then you push them to the desired depth, and then this is connected up to like a small data logger that's got the telemetry that pushes the data out, and that's mounted to a post like this that has got a solar panel. So it's all kind of, it's transmitting data, it's collecting power from the sun, and it's just kind of operating. But then you would want to probably retrieve that before harvest.
So how long does it take before the sensor is actually giving you a good reading, like the soil and everything gets back to what it would be everywhere else where it hasn't been disturbed?
Right. So the recommendation is you soak this in water overnight before installing, and then it takes about 24 hours for it to kind of dry out. The soil's kind of pulling water back out of the sensor till it reaches that equilibrium with the soil. So it's about a day from installation till what we consider high quality data. Yeah.
On the site that you guys have, do you see very much soil texture changes? And over the last bit with all the rains, have you seen an infiltration rate difference between that, or like, is that kind of the data that you'd be able to see?
Yeah, absolutely. Yeah, so you know, I just provided on this handout just this one plot where the near surface was quite dynamic, and this was the most this was the part of the field that had the most dynamic responses. The lower lying areas, the response was more muted. And that's partly, yeah, there's you know, more clay buffering things at some of those lower positions, and yes, we are seeing some dynamic response differences between locations.
And the field is, I mean, probably similar in variability to this one. It's, you know, it's got some appreciable hills. I don't remember the exact elevation change. It's 3 meters for sure. Like, it's, you know, it's not a flat field, and it's something that they've had challenges, you know, kind of with water pooling in certain areas. So so I expect as we get into, you know, a little more water coming down or being irrigated in the next, you know, 3 or 4 weeks, we'll start to see some of that differentiation in this area and this area, and hopefully we can kind of do a good job of managing some of that.
So if you commercialize this, what kind of cost are we looking at per quarter?
So our target price right now, we should go on market in 2023, and the sensors are going to be in the $100, $120 range, and then the communication part is another couple hundred. So for each kind of point, you're looking at probably $500 to $600. And then in the field, I would think 2 sets would be kind of the minimum. 3 might be better, depending on how much variability you've got. So it's in the kind of $1,000 to $1,500 range.